I chose a few problems from the homework on 2.2. I just want to make sure that we're doing correctly. The first one I want to talk about was number 10. Just make sure that remember what a description would include. So on number 10, they gave us the scatter plot. They said this one was looking at the grade point average and IQ scores for different seventh graders. But the big thing was they want us to describe it. So anytime they ask you to describe the scatter plot, remember we have 4 things that we're going to look at. One of them was what's the direction that we're going. And for this one, that wasn't too hard to see that as we read it from left to right, it's going in. So we should have had a positive direction for that one. The next thing was the form. The form for this one, what do you think this one was? Linear, exponential, quadratic. This one, exponential, would mean it really takes off, so it's going to level off. Yeah, it's probably linear. The strength. Now, when you did this, we hadn't talked about R value yet. They didn't give me the specific values anyway, so I couldn't really compute the R value, so I kind of just went off the looks. So what do you think? Does it look strong or weak? Say they're pretty bunched up or not so much? Okay, take a shot at it. Strong, there you go. That's what I go with. They're pretty close together there, so at least that'd be strong. Now, remember, we're going to have a better way of doing that, and we're going to fit it in one of the 5 factors. But this one, you just had to look at it. And the last thing we're going to look at is anything that looks like an outlier. We've got a couple points that kind of seem a little bit low, maybe a little bit high. But if I really draw a line through there, I don't know that anything is like totally way off. If you said something about this low one, I could maybe take that as an outlier. It's kind of a little bit off of that line, or quite a bit off that line. But again, we don't have a great way of making that decision yet other than our looks. So if you said none, that'd be all right. If you said that low value, that might be acceptable as well. I'd probably lean toward none here, but that one's kind of a trickier one. When we get to like quizzes and tests, if I ever asked you that, I'd make it pretty clear that it's an outlier. So just a reminder, these 4 things should be involved in your description. Remember they ask you to describe it. Then these 2 problems, 15 and 16, I thought they were maybe worded a little bit confusing. But on number 15, they wanted us to draw 2 scatter plots, and we could just sketch them. They didn't have to be specific. But draw 2 scatter plots. They said both of them are going to have strong positive associations. Here was kind of the tricky part. They wanted different forms. So remember, the forms we could have would be linear, quadratic, which means it's like a parabola or an exponential. If it's strong, that means all the points are together, very close together. We know positive means it's going to be increasing as we go along. So let's say I made one that was linear. That's probably the easiest one to make because that's more like what we have been doing. So I would just want to make something where they're close together and they're going upward, but it looks like they're in a line. Okay, so that would be one form. If I decided to make one that was maybe exponential, again, the points should be close together, except now it's going to increase pretty quickly from there. So that would be an example of strong because they're close together, positive because they're going up, but they have 2 different forms. Could I make a quadratic that's positive? What's the tricky part with the quadratic? I thought about the shape here. As I go this direction, what starts happening first? Does it go up or go down? Yeah, it goes down, right? And then eventually it goes back up. Well, really, if there's a strong direction, as we go from left to right, it should be going up the whole way. So it's kind of hard to make a positive one. This one would be okay because it ends up in the positives, but probably exponential would be a better example. So, like I said, that was kind of a tricky wording, I thought. 16 hopefully was a little bit better because they wanted two positive linear ones, but this time they had different strengths. So maybe make one that's strong, just like we did a second ago, one that's close together going up. But the second one, maybe make it weak. So maybe you still have a linear situation, they're just more spread out. Okay, so this would be an example of a strong positive, and this would be a weak positive. But they both be linear. So hopefully that helps with those problems from 2.2. Well, Monday we looked at R values, but when we did the R values, it kind of took a while, right? We had to fill in that table. We had to do a lot of computations. So today what I want to do is I want to show you how you can do it on the calculator. So the data we're going to use is actually from one of the homework problems. It's this data here. This is the data used on number 5. So in your calculators, what I'd like you to do is I'd like you to enter the speed from this column into L1 and then put the fuel used into L2 in your calculators. So why don't you go ahead and enter that data in. Always make sure that you have the same number of values in L1 as you do in L2. Like I said, that was the data from number 5. So hopefully, if you did the homework, you made that scatter plot. But if I asked to find the R value for this, or the correlation, remember we said that was going to tell us 2 things. It was going to tell us the direction and the strength. But we had a lot of steps that we had to do last time. So I'm going to show you on the calculator how we can find that R value a lot faster than having to go through all those steps. Now, the first thing that we're going to do, we only have to do once on the calculator. But in order to find the R value, we have to take care of this step. So on your calculator, above the 0, it says catalog. So I'm going to hit second, and I'm going to hit 0. And what the catalog is basically every function the calculator can do, it lists on there. And all those functions are in alphabetical order. So if there was ever anything you couldn't find on the calculator, you could go to the catalog, it would be there. But what we're going to search for is, we're going to look for what's called diagnostics. So I'm going to have to arrow down all the way into the D's. And what I eventually want to do is I want to turn the diagnostics on. So I'm going to get it to a point where that little arrow is on diagnostic on. And go ahead and hit enter once you do that. And it should just say diagnostic on at that point. If you hit enter again, it'll say done. Now, like I said, once it's on, it should stay on. You shouldn't have to do it again. Okay, so it should be set up now. But we have to have that on in order to find the R value. All right, finding the R value for this data. We're going to go to stat. We're going to go over to calculate. And then we're going to go down to number 4 that says LINREG. That's linear regression. We're going to go down to number 4. We're going to select that one. Now from there, your screens may vary. How many people have a screen like this? Okay, if your screen looks like this, just go down and calculate. If your screen just says LINREG, if it just says linear regression, that's it. What you're going to do is you're going to hit second 1 to tell L1. You're going to hit the comma, which is above the 7. And then you're going to hit second 2 to tell L2. So basically you're telling it it's an L1 and L2. And then you guys can go ahead and hit enter. Those of you that went down and calculate, you can hit enter. And you get a whole bunch of numbers there. But the one we're going to pay attention to is the R value. We're going to pay attention to the R value. This one right here. So the R value for this data was R was equal to negative 0.10, which tells me the direction is negative. What would the 0.10 mean if I look at my table? Very weak, right. Now, does that seem to match my graph? Does it look like my direction is negative? Not really, right? It kind of starts out this way and then it goes back up this way. So it doesn't seem to fit my graph as far as the direction. Does that graph look weak? Not really. It looks like they're kind of all in line. So I wonder why we got an R value here that was negative and weak when that's not really what our graph looked like. Well, let's back up to some of the other descriptions for a graph. What's this look like? Which of our forms does it look like? Yeah, it looks like a quadratic, doesn't it? It looks like we have a parabola here. And that's really what we have here. We have a form that's a quadratic. Well, if you remember when we talked about R values, We said we can only use R values when what's happening. What kind of form did we have? Linear. And since this was not linear, I really shouldn't be looking at the R value for that one. Okay. So I just want to point out again, we're going to deal mainly with linear situations, but not every single situation is going to be linear. In fact, this one wasn't parabola, it was quadratic. So the steps we found for the R value are going to work whenever we do find them. I wanted to show you that on the calculator. But also I want to remind you that sometimes we don't want to use the R value because this was not linear. If it's not linear, then the R value really isn't something that we're going to look at. Okay, so just a reminder on that. But as far as if I do have a linear situation, I can enter in my values for X's and Y's. I can do my stat calculate, go to linear regression, and now the R value should show up. And so I don't have to go through all the steps we did by hand on Monday. That was really the last time we had to do that. So today what we're going to do is we're going to do an activity here to kind of practice that correlation idea. So I'm going to hand out the sheet first, and then I'll tell you what I want you to do with it. All right, first thing you're going to do here